Over a period of time, Jasper has found that the probability of a patient having a particular genetic marker that he is trying to investigate is about 6%. So if we say that that's a success, then we know that P is 0.06, and therefore Q is 0.94. He wants to take a sample of patients and would like to be 95% sure that he gets 3 or more patients with the genetic marker. What should his sample size be? Well, what we should do first of all is define x as the random variable, number of patients with the genetic marker, and then x would follow a binomial, and we don't know what the size is, but we do know that 0.06 is the probability of success. So what we want is the probability of x being greater than or equal to 3 is greater than or equal to 0.95. And that's the same as probability of x being less than or equal to 2 being less than or equal to 0.05, since these must add up to 1. So, remember, this means that x could be 0, 1, or 2. Now, on the calculator, I have tried just solving. So action, advanced, solve. 0.05 is equal to, and then going for the discrete distribution binomial CDF. We want that to go from 0 to 2. We don't know the number of trials, so I'm just going to bung x in there. And the probability of success we know is 0.06. And it thinks about it for a second, and it doesn't like it. It won't actually solve it. So what I had to do in the end was actually think about this distribution. So if we have no successes, that's 0.94 to the n, and then we'd have nc1 0.94 to the n minus 1, 0.06, and then we'd have nc2 0.94 to the n minus 2, 0.06 squared, and let's put that equal to 0.05. I just need to move the calculator over a bit. And we can shortcut slightly here. nc1 is just n, and nc2 is n minus 1 over 2. It's going to be quicker if we evaluate those expressions. So I am going to go for action, advanced, and solve. And I often find it's best to put the actual number on this side when we use the calculator. So that's going to be 0.94, and I'm just going to put that to the power x. Then I have 0.94 to the power x minus 1 multiplied by 0.06, and don't forget the x, that's the x that was in front here. And then we've got the nc2, which is x bracket x minus 1 over 2, and that's got to be multiplied by 0.94 to the power x minus 2 times 0.06, and that's got to be squared. Execute that. Now, even on the computer here, it takes a bit of time, so it's going to take a little bit of time on your handheld, but it does give me what's a turns out to be a sensible number because I've checked it. Gives me that n is 102.7 and so on. And that suggests to me that we need to go up to the next one. So n is 103. So the sample should be of size 103 to make sure that this is actually less than 0.05 and this one therefore is greater than 0.95.